And thank you all for joining. First of all, to be honest, we were really nervous when we talked about this event, right? We were not sure in the Bangalore traffic how many people show up. It's great to see a lot of rows filled. So this is very nice. Thank you all for coming. So still further, okay. All right, okay, super. In this talk, I'm going to talk about, I'm sure most of you are like either working on AI or someone working on AI is pinging you, I'm building this cool stuff. You hear about ChatGPT, you hear about real-time AI, generative AI, what are you doing, right? There's a lot of noise, a lot of excitement, right? What we are trying to do is set context on what's really happening, what is real-time AI, and how streaming plays a critical role in your AI projects. So the idea is we will start with a simple example and demonstrate what is the role of streaming and how you can leverage that.
Can you share your screen, please? There are folks online.
I am sharing, I think.
Is it shared already? Okay, okay, sorry. Yeah,
okay,
go ahead.
Okay, so in that context, how many of you are working on AI projects? Okay, few. Okay, I think I should have asked with how many of you are using Pulsar today? Okay, good. That's good. That's good. How many of you are new to Pulsar? Haven't heard about it, new to Pulsar? Super, super. I think this is a good mix. So we'll spend a little bit of time talking about AI. What are the use cases we are talking about? How many of you heard about real-time AI? Real-time AI. Can anyone give an example of what real-time AI is? Can you have mic, folks? Sorry, go ahead. Yeah. Voice assistant like Siri. Okay. Good example, but it may not be real-time AI. Let's come back. Okay. Anyone else?
Fraud detection.
Fraud detection. Yes, great example.
Right.
But he knew the answer, so I'm not discounting him. Anyone else? Self-driving cars. Self-driving is a great example. Again, we didn't talk about what real-time AI is, right? But when we mentioned real-time, you picked up right examples. A series is a good example, right? So all of them are good example. Why do you think this is a real-time AI? And if there's a real-time AI, is that like a non-real-time AI? What makes this self-driving cars a real-time AI? Make the decision on the spot. It needs to know what is happening around at that point in time, in that context, and then make a decision, right? So that makes it real time, right? So let's take example. I'm sure most of you are aware from academic perspective what AI is, what you're doing. So let's spend time talking about the foundations of real-time AI. How can you build real-time AI applications? What are the components you would need? And then we'll touch upon the role of streaming. Okay. So I'm going to start with a demo. This dais is too small, so I'm just going to sit down so it's easier. I hope you're all able to see my screen. So for this demo, so we will share all of this. So this is all published in GitHub, so it's open. So we will share these links after this session, so you can go play with it, right? So step one is we are going to start from scratch and see how to build an AI model. Then we are going to talk about how can we make this real time, and then what real-time AI really is. Okay. So to do that, first is I'm not going to explain you what real-time AI is, but we will come back to this later. We will try to define that at the end of the session. For this demo, I'm going to start with a very simple data set. So for folks, if you're not familiar, there is something called Movie Lens. They provide academic data sets for research and learning purposes. This is related to movie data. So what this data has is, it has a user ID, it's a movie ID, and a rating. So the idea is a user watched this movie. For example, if you look at the first row, user watched this movie 1 and provided a rating 4.0. Okay. Similarly, there are like thousands of records of this. This is the data set. So for good. So we have a data set that we can use to train a model. What we are going to do is, I'm using TensorFlow here, but that is not important. We're going to train a model, and our goal is given a user, we want to get top 5 recommendations, movie recommendations, what this user will watch next. So far good? Given a user, give me top 5 movie recommendations for that particular user. Okay, so now let's quickly jump into the code. And for folks who are new to AI or machine learning, I just want to clarify some concepts, right? We have this 4 fields here. I mentioned only about user ID, movie ID, and rating. So there is this concept of features and labels. So features are inputs to your models that you use to train, and labels are things that you're trying to predict. Okay. So here I'm going to use user and movie ID as features, and I'm going to train the model to predict this rating. So again, as I mentioned, this code, how it works is not really important, but I just quickly show you. After we create a model, we pass user ID and movie ID as features, and we are trying to train it to predict the rating. Okay. So now let me go ahead and run training. I hope you can still see my screen. Let me make this bigger. Okay. So train.py. So this model, so I have this data set in a CSV and stored in my local disk. So this is going to run training 10 times over the data set, and then it will save a model. Okay, so the model is ready. It basically saves into my same folder, movie recommendation. So now let's try to get predictions from this model. For predictions, the goal was you pass a user ID and we want to get top 5 movies for that particular user, right? What you're trained is, given a user and movie, this model will predict the rating. That's what we trained for. Now the use case, the goal, what we want is, given a user, give me top 5 movies. Problem statement is clear, right? Now how we are going to do this is, anyone want to try how we are going to do this? We have a model. You give a user and movie, it will predict the rating. So based on rating, we can know whether the user will like or not. What we need to do is, for a given user, we need to get, let's say, top 5 movies. Okay. So what we will do is, we are going to get a rating for all the movies available. For a given user, we are going to ask the model to generate a rating, predict a rating for all movies. And then we are going to sort it and then pick up top 5. So that becomes my top 5 recommendations. Good? People following me so far? Okay. I think if you get lost here, it will be very difficult next 40 minutes. So far good, right? Okay. So now let's look at serve. So here we get all the movies and we get predictions for all the movies for this particular user. So now you know all the ratings. Then I sort and pick up the top 5 based on how many number of recommendations I want. So while running prediction, so what I'm doing is I am passing, hey, for user ID 1, give me 5 recommended movies, right? So now let's go ahead and run this. So after it runs, you can see it lists, it gives me 5 movies for this particular user. This user ID is 1. It gives me a list of 5 IDs. So far good. I think one key point you want to notice is, irrespective of how many times I run this, it is going to give the same values, right? Because the model is trained, unless you have new data and you train your model, this will always return the same result. Agree, right? Agree? Okay. Now, I think this is very simple to see from numbers, but the real manifestation is, I have like a sample app that basically shows how this is going to work. Now, let's say you have this Netflix kind of an app, right? Now, if this is your model, just to be clear, right now you have a machine learning model back. I mean, this application backed by a machine learning model, right? It tries to get prediction for the user, right? But when I come here, I see a lot of movies based on the prediction I got. Now, as a user, I might go here, like, let's say I watch this movie, I rate this movie, and I watch this movie, I rate this movie, I don't like this movie. But when I refresh again, nothing changes, right? Because you are still relying on old data. The model, unless you retrain your model or pass this new context that this user has watched this new movie, you're not going to see anything new. So user is going to still have a stale experience, right? So this is the gap with most of the AI models, right? You have batch data, you use it to train your models and use it in prediction. You call it, your app is AI powered or ML powered. You can put a label, but if it is not having access to real-time data, the real-time context, it is not really useful for the user and for your business. Good, right? So now let's see how can we take this and add some real-time features and make this more useful. Okay. So now what I'm going to do is, let's go to our GitHub. So if you notice here, so I have movie ID, so user ID, movie ID, rating, and I also have timestamp. So timestamp is interesting because I know when this user watched this particular movie. I know user 1 watched movie 1 at this milliseconds from epoch, right? Based on this, what I can also do is, I can also find out what was the movie this user last watched before watching 1. From the timestamp, I can find what movie user 1 watched before watching user 1, right? So that can be another feature I can use to train my model. So I can have some historical context on or time-based context on what user activity it is. Again, I'm just stating what is obvious from this, but there could be so many other ways. How can we pull more time-based information, right, for real-time context? What you can also do is, you also know what was the last rating user provided, right? So this is at a very high level, what we usually refer to as feature engineering, right? So you have this data set. Now, how can we extract more information from this data to create new features? So there are like a lot of fancy terms, feature engineering, materializing features, all of that stuff. That is all very well related to streaming. We'll talk about this soon. But this is what it is, right? You have data set, you find ways to extract new information that will be useful for your training. Okay, so this is what we will do now. So now what I have done is, with like bit of scripting, you can engineer these 2 new features. Now I have a watched movie, last rating. And I have this. Now what I can do is, now I have, remember, these are time-based features, right? Every time a user watches a movie, this value will change. There'll be a new record and this value will change, right? So this is important. Now, from this data set, what are the features I can use to train my model? So now I have this new features, right? I mean, obviously I stated the answer. So now we have new features. Now we're going to use all the new features to train my model. So I'm going to pass user, movie ID, what is the last watched movie, last rating, and ask it to predict what is the rating this person is going to give for that movie. This is important. I mean, from data, it looks simple, right? But if you think about it, it also captures the current mood of the user. For example, like say he's binge watching, right? Maybe I typically watch, let's say, comedy movies. Suddenly I start watching horror. Like maybe if it's trained on my old data, it's not going to, it won't even recommend that movie, right? But if it captures that intent of the user, no, or some reason I want to watch horror movie, then it's going to give better recommendations, so I can stay on the app and continue working with the app, right? So now let's look at the example on how I'm going to train this. Train real time. So it's very same model, but only thing what changes is my features. Now I'm going to pass 4 features instead of 2 and train it to predict the ratings. Okay. All right. So let's go ahead and run this. This is training real time. So let this complete. One other thing you would notice is, if you remember, right, we actually changed the features of the model, right? Which means we didn't convert your existing model into a real-time model. We actually created a new model. Whenever you add a new feature, it becomes a new model. It's not a new version of the existing model, right? So that's another thing you have to keep in mind. Now, training is done. So if I look at my serving code, it's exactly similar. Now I'm going to pass additional features to this model. So user 1 gave a rating of 4. This is the last watched movie. And what is the rating they give? And I'm asking to give 5 recommendations. Now if I go here and run Python tree serve real time. Sorry. So I got a response. Now it's very similar to the previous example. How many ever times I run this, I'm still going to get the same results, right? It is real-time model, right? But it's going to still give the same results because my input to the model is still the same. Even though I train with new data, my input is still the same. So the real time in this example is the data, right? If I pass, okay, user watch this movie. If I pass this new information to my model, then it's going to produce new predictions. For example, let's say I just rated, let's say watched movie 5 and I didn't like it, I gave rating 2. Now if I come back, I'm still trying to get prediction for user 1. Now when I try and run here, now hopefully you can see, I think there's one movie that's still there, but the rest of the things have changed. So I get a new set of recommendations, right? So the real-time in the real-time AI is primarily with the data, right? How can we get real-time data, real-time context, the user intent to your model at the inference time, right? You might be having models, AI models that does real-time inference, right? I think that's an important distinction here, right? You might have a model, user comes to your site, you might call your ML service, get predictions and show it. Not me, right? Okay, I think it's not me. I completely lost my train of thought. Okay. So real-time inference. Okay. So real-time inference, you can have a model that trained with latest data. When a user clicks a button, you go get inference in real time. That's called real-time inference. It becomes real-time AI only when you pass the real-time context to it. Okay, what that user doing at that point in time? And it is not just the scope of that user, right? Or the app. Obviously, you are work for large enterprises, some startups, but there's so many systems, right? You have signals everywhere. How can we catch all the signals and make it available to your models with the right context at that inference time? That is what makes real-time AI magic, right? And if you're able to deliver this contextual recommendations for user at that time, then the user will love it. He will stay in the app. I mean, this is true for any application. You are an e-commerce company. You want user, when they search a product, you want to show the product that the user would like or high propensity to buy, right? It is true for any industry, any vertical. Now let's quickly take a look at the app, how it's going to behave, right? So now I have put a nice button here called, so far we are using the batch AI, right? The of batch real-time inference, but with old data. Now I'm going to switch this to real-time AI. So now watch here, right? So I have these 5 movies. Let's say I try to watch this movie. So remember, this movie is going to change very quickly. I need to fix this in the demo, but I didn't get time to do that. So I'll say I watched this movie, October Sky. I hated this movie. So if I rate this movie, you would notice in the background, all the movies would change, update based on, because I'm calling inference API with this new information. There is a user intent happened. I watched the movie, I didn't like the movie, and I come back here, you can see that the list has changed already, right? Now, this is a very academic example of what real-time AI is. You cannot do this for real life in production system, because I think there's one big mistake in this so far demo. In this academic demo, I just show for like simplicity, but there's one big mistake here in whatever process we have done here, whatever process we use to do inference. Can anyone take a guess? What is the problem here? So this is my serving code, right? It's not really a problem with the model, but the approach, right? From an architecture perspective. So this is how my serving code looks like. Okay, maybe this is easier, right? So my application is passing these values to this model during inference. It is passing user ID, it is passing the last watched movie, the October Sky, and the rating, and asking me to get a recommendation. It works academically, it works, right? We showed it works, but it is not practical in a production systems or your real systems. Anyone take a guess? Sorry? Every time you're taking manually, we are still talking about serving, right? Okay, I will come to training. So real-time training is another problem, right? Just talking about serving. New feature get added, but that will be a new model. But that's a good point. New feature get added. Application may not know what the new model is, new feature is. Exactly. I think you're onto something. Yes. Anyone else? Last chance. In the interest of time. Okay. Correct. So one is not practical, like he mentioned, right? The model might have changed. New version of model came in. New model came in. That's one. Second is most times your application, the UI, in this case is my UI, right? Or no single component will have total visibility into what are the features it needs. This is a very simple example, right? Let's say you are e-commerce, right? E-commerce company, you get the top 5 recommendation from your model. But if the inventory system says there is no stock, there's no point in showing this at all, right? So that's a signal from your inventory system. You need to have that. So there is no one single system that will have access to all the features. In some of the production systems, what we are seeing, right? We see people use like hundreds of features, hundreds of raw features. And in typical machine learning world, right? I think for people who are familiar, you can talk to your friends. They take the raw features and there'll be a lot of transformation they will do on that. Like they will just randomly do a log of things, window aggregates, so on and so forth, right? So the number of features, you will end up in thousands. So no one application can give you all the features required to prediction. So you need a different system on how your model is going to find all the features. So far good? No? You didn't follow. So in this application, right? This application is passing all the features. It has access to all the features. But in real life, no application will have access to all the features. You would have hundreds of features, if not thousands. So it will be practically impossible for one system to fetch all the features from so many systems and pass it to a model. That will be prohibitively expensive, both from time and value perspective, right? So we need a solution on how your model is going to find these thousands of features in real time with the right context. So that is the problem you need to solve for. So far good? Okay. All right. I think with that, I will stop with the demo. I have few slides to talk through how we are going to define this architecture and also talk about, more importantly, right? This is a Pulsar meetup. We haven't talked about Pulsar at all so far. So I think let's get to Pulsar. Okay. But before that, real-time AI is clear to everyone now? You all can talk about real-time AI, right? Perfect. Okay. So now let's take a step back. I'm going to like recap whatever we have done. I think I have about 10 minutes. I think we should be fine. Somebody wave if I'm going over, okay? All right. So where we started? We started with the data set, the movie data set. What we did is we used it to train a model and we built an app to get predictions, right? So at this level, like most people, from academic perspective, yes, I have a AI powered app, right? But this is not the end, right? I mean, it doesn't stop here. Even for academic purposes, after you build this app, you want to know how the model is performing in real life. You have the predictions, but how do you know if the predictions are useful? If the user is actually liking it? You might have trained the model, the training accuracy might be awesome, but in real life, you show a recommendation and user is not clicking on it, it's useless, right? So you need to have visibility into how you manage it. So that's where the concept of prediction store come in. So what typically happens in a machine lifecycle is all these predictions you make are usually stored in a prediction store for analysis of the performance of your model, right? How it is performing, and then also use it for training your model. Like how can you train this model again? This is also important, right? So we talked about training in the past. So if you remember, right, we had the initial data set. We trained that model using the data set. Now, obviously, when you deploy this, you're going to get new data. That's what go to prediction store. You use that for model monitoring, analysis, and you also feed it back for incremental training. That's how you fine tune. This is one of the technique on fine tuning your model for better accuracy. So the model knows maybe there are new kinds of user coming to the platform. So it can track and learn about these patterns. So you use model monitoring for fine tuning the model. You use prediction store, feed it back to dataset for training. So this actually covers a good life cycle on what other things happens in a typical machine learning AI project, right? And obviously, this is a very simple example. I just download the CSV and loaded it on my laptop, trained it, right? In real life, that's not the case. You might have like a lot of data that cannot fit in my laptop, cannot fit in one machine, right? You need to be able to store in a scalable data store and then use it for, find ways on how can connect your model to read from this data set, right? Same for prediction store. So you typically have, it's not CSV files anymore. You would typically have databases or some kind of data stores to manage all of this, data lakes and whatnot, right? The model itself is very, the example was simple enough because it's academic example, but real life, there are several machine learning pipelines. People talk about ML ops, right? So there are specific platforms that does all of this. You have a training pipelines, you have serving pipelines, you have model registry. You may not build just one model, you will build dozens of models. And each model could have a number of versions. You will have checkpoints. So you need to manage all of this. So you will have model registry kind of stuff, right? So I'm just going to try grouping all the database components. So in the machine learning world, so usually the way how you store your training data, how you store your predictions data, how you store your inference data. So there is a concept called feature store that provides a data model on top of, there are a number of databases that supports feature stores. Feature stores is like a database design technique that allows you to manage your training data, inference data, or features that you need for inference, and store prediction results for model analysis in a developer-friendly way on how model can access it, right? So typically you would have build some kind of feature store applications on top of your database to store all of this. So I'm bringing all the data to one side. So that's the data store part. And there are a lot of AI platforms that supports training, serving model registry. I'm sure you are familiar with like Vertex or SageMaker. And there are obviously there are a lot of folks done homegrown platforms to do all of that. So far good. So so your training data, inference data is your database. You build your models in the AI platforms, use it for training, all this stuff happens, right? But still there's one key piece missing, right? Which is how do we capture the context, the real-time context, the events that are happening all over the place, and making it available both for training and serving, right? That is the problem we talked about, right? There could be thousands of features, and the source could be so many places. How can you bring all of that and make it available in this data store so that your AI platforms, models running AI platforms can get access to it? I think that is where the streaming comes into play. So I just moved the feature store, prediction store. This is where streaming comes into play. Streaming plays a part on capturing this real-time data from your app, not just one app, from across your systems, and process it. The process part is, it could be as simple as simple transformation, mediation, whatnot. It can extract features. It should be able to extract features from real-time data. And once it knows this is a feature, it goes to your feature store and updates it for training, whatever. If it is for inference, it updates the inference database. If there's a predictions coming in, it goes updates the predictions, prediction systems. This is the role of streaming in this overall architecture. I will touch upon some of the use cases what we see in this space. I'm just trying to rearrange all these pictures so it forms kind of a value chain. Are you guys able to follow so far? Good. Any questions so far? All right. Okay. So as I said, right, so it's not just one app. You need to bring in all this data from so many different systems, make it available in your data store so that your ML models can access it, and you will be able to deliver real-time AI applications. So let's quickly talk about what capabilities you would need in the stream processing. Again, it's not much of Pulsar talk, right? It is about how event streaming is really important when you're building a real-time AI architecture, right? I will stop at that. I think we have experts, Shivja and others, our friend Vikas, who will actually talk you through why Pulsar is better suited for these use cases, right? So what do you need to do here? Like, what are the core capabilities that you would need here to build real-time AI applications? One, obviously, it has to connect. It has to like insanely scalable. It has to connect to all kinds of systems, high throughput, low latency, all the stuff. That is table stakes. I think we'll talk about it. Second, the processing, right? So you need to be able to extract information from the raw data. So I'll give you an example. The movie example we saw, right? When a user rates a movie, the information that is available to the app at that point is, app knows who the user is. It knows what the movie is. It knows what the rating is, right? Now only these three information is available at that time from the app. Now when it comes back, following so far, user watched the movie, provided a rating. These are three fields that app knows at that point in time. Now typically what happens is it will create an event and push to your streaming system. Hopefully it's Pulsar. Now what Pulsar needs to do is, it knows this is an important signal. It is used by my model. I mean, obviously that's how we'll design it, right? It knows this information is useful. It is used in my feature. Now what you need to do is, it knows my feature is not just this. I also need to know what is the last movie watched by this user, right? It may not be just Pulsar, but I'm just stating the use case. So this stream processing needs to be able to go fetch for this user what is the last watched movie, and enrich that information, event information, add this new field. What is the last rating? Add this new field, and then write it to my, where will write? Online serving, right? Because it is needed for serving. Now, I think this is also important, right? If I am watching a movie, I did a rating, I'm done. If that event is captured by the streaming system, and if it reaches online serving database in time, and it's in time, before I, let's say, refresh my page or before the app calls recommendation, if all the data in motion happens and ends up in online, by the time the app tries to make a recommendation call, the app will receive the latest recommendation based on this new data. User is happy. If obviously you still have a pipeline, but you have set up a pipeline. If there is a delay or whatever reason, when the app makes a recommendation, if it still has the old data, you serve a wrong recommendation or a stale recommendation, user is not happy. As simple as that, right? Now, obviously, when you talk about this, right, you know the latency requirements now, like how fast can you get it here? You are talking about before the user makes another action, you want to get the recommendation. So we are talking in the order of milliseconds. Can you get all of this done and get it here in sub-millisecond latencies? That's one. Second is the last watch is a very, very simple example. Typically, if you look at real world features, people will do time window based aggregation. Okay, what happened in the last 5 minutes? What happened in the last hour? What happened in the last week? So there's a lot of time window aggregation that people do. So your stream processing needs to be able to do all of that. Third, what is even more interesting is data defined time intervals, right? So give me last 5 minutes, give me last 30 minutes, super easy. I mean, obviously not super easy. It is possible. We all know how to think about it, right? How that feature will manifest. Data defined time windows. this is, for example, let's say browsing. Okay, let's take another example. Let's say I'm watching a live stream, right? I can ask, after I started watching the live stream, how long, I mean, what are the actions I did before I quit the live stream? It could be comments, it could be likes. There's no fixed time. I could start watching a live stream at any point in time. I want to aggregate what are the actions I did during my time watching the live stream before I quit. There's no fixed start time and end time. It's based on the user action, right? And this user action is captured in the data. So based on this user data, can I define time window intervals and can I get aggregates? So these are possible with open source project Cascada that allows you to do time window based aggregation defined by data. What is also interesting is you can also find events. When we talk about events, right, we always relate to it. Oh, there is something happened. Something happened, that's an event. Something that doesn't happen is also an event. Let's say you expect the user to click this movie or write a comment, but he doesn't do it. That is also an event, right? I know some people are dozing off already. We should probably do a tea break after this, I think. So far, good. I want to. This is a really cool concept, but I know I failed in my attempt to excite all you guys. The absence of event is a really interesting feature, and what you have seen is it has a lot of the useful signal and potential in improving the model accuracy, right? So you can define a defined time window that says if a user doesn't do any action in this, create an event and capture it as a feature and use it, right? So there are a lot of interesting possibilities on what you can do with streaming and stream processing. But the primary role of this component in the overall real-time AI architecture is capturing data from all the different sources, high throughput, low latency, and extracting features, right? Extracting features, materializing them, and making it available to your models at the right time with the right context. That is the key. To expand on that, so obviously I wanted to put like some logos here, just to so you can connect to. I mean, you might have probably heard all of this. You want to say what are the role each component plays. The streaming, you have Pulsar. I hope, I don't know. I had a big debate about with myself, should I put Kafka there or not? But I think it's only fair we put there. We'll talk about, we should talk about Pulsar Kafka. So I put Cascada. Cascada is really cool. It's also open source. Just play with it. Data store, AI platforms. And then this is probably a pretty slide that basically captures that. This is what I want to start with. But I think I got feedback that, hey, people might be confused. So I want to see if we can build from scratch and eventually get here where everyone will agree. Hopefully it all makes sense. Do you all agree? This is a foundation for real-time AI architecture. Okay. Super. And that's it from me. So thank you all. Thank you for most of you for staying awake. I'll be here. So if you have any questions, feel free to catch me. Happy to talk about AI.
We still have 5 odd minutes. So if there are any questions, you could just ask. We have the mic here.
I have a lot of questions I can ask. You guys have a lot of questions.
Any questions?
Can you just go to the last slide? Last slide.
Not this one.
Just before that and before that. Yeah, exactly.
Yeah.
So I had a doubt, we are using the real-time data from the app and sending it to the data store, right?
Yeah.
But we are not doing all the processing of training and serving at the real time, right? Because you're not how is that happening?
No, so I think I missed the arrow here. So the goal, the scope of this architecture is for real-time AI applications.
Okay.
The idea is it collects all the data and makes it available in the feature store.
Okay.
So your ML models will pick up the data from feature store for training and serving.
Is that also real time?
I'm sorry?
Is that also real time?
Yes. So this needs to update in real time. So,
right.
Okay. So the application, I think this slide is probably easier. So the goal of this architecture is, hey, this is the setup you would need to deliver real-time AI.
Okay.
And yes, you need to have streaming and stream processing connecting to all the systems. You capture all this data, make it available in the feature store,
Okay.
so that your ML model can fetch it with the right context and deliver recommendations that user will like.
Okay.
Okay, cool. That's a question.
Any other questions?
Yeah.
Can you give an example feature, any real time where data defined time window is important?
Oh, that's a good question. So data defined. I'm just trying to find a domain that will be relevant. So e-commerce is usually, I mean, I've seen a lot of examples of e-commerce world. So things like how many searches a user did from the last purchase. From the last time they placed the order, how many searches they have done. After user added a cart, how many times they went back and searched for another product. So these are, I mean, at a very high level, like these are some of the things people are doing. But I think the consequence of that is, like, if user add an item to a cart, and if they still go back and search, probably the model will learn something. Maybe the recommendation they did in the first place, maybe it's not enough, or the user didn't like it. They still have doubts. So next time they can use that information to deliver a product that they will add to the cart first and just go with it. Right? Time window is the time from the last order, like user would have placed last order. Between two windows. The window is like the start window and end window. You don't necessarily need an end window. You only have to define a start window. And I can say, now, user might have placed order last week or this morning. I can ask how many searches this person has done now, till now, from the time they last placed the order. That's the dynamic time part. It's defined by data. Second is if you're like the video platforms, right? So they usually capture the absence events after they join like a live stream. Mostly after live stream, are they interacting with the comments or did they like it? So they have like a time window. The last 10 minutes, did the user act or not act? So both are events. If the user is not interacting, then they will proactively recommend other streams or videos to the user. Right? So they try to capture attention based on the user actions. So there's some use case around that. These are all dynamic based on data. One last question from me. How many of you use ChatGPT? All of you, yes. No, right? I just want to, like, I mean, again, I talked a lot about AI and all this stuff, but I'm no AI expert. I'm not a data scientist. All this code, right? I showed you the demo. It's all done by ChatGPT. I just asked, hey, I want to build a recommendation model, right? It just basically gave, I know like what I want to build. I want to tell a story, recommendations. I gave it, I was super shocked. Man, this world has changed now. I don't have to be a developer to write any of this, right? This is so awesome. I think we're also doing a lot of stuff with generative AI. I mean, if you guys are doing, if you want to talk, I mean, we are here. So I'm happy to talk, share ideas, learn from you guys. Thank you.